I spent a few hours studying Simscape and trying to make a model of a mobile robot because I think it can be a very good and interesting platform to play around with control strategies and show some interesting things. And I'd really like your feedback about this. If you think this could be useful, if you think we could do something interesting with that. We could do other type of vehicles. We could do probably flying vehicles, maybe vehicles on water, underwater. I still need to learn, but I think it's interesting. So I'm starting here from the result. So you can see this is the robot, and these two are the wheels, which I used elliptic solids for those, and they are actuated, so they can only spin around the horizontal axis here, like a virtual axle. And then I have a sphere on the front, which is not actuated, it's free to revolve around a spherical joint, and it's there basically to reduce the friction, and otherwise we would be touching the ground with the body of the robot, which we don't want. And we can see a bit more here on what the result is. So this should be good. Let's see, let's play the video. So this is my simulation, what it gets to. And I have no control for now here, okay? So this is all torque generated for the wheels simply by generating the torques as a profile, just to see if the model does what it's supposed to do. Okay, let's see some configuration. I don't want to keep this video too long, so I'll try to do various videos going more in the detail later. But these are a few configuration parameters of the robot: wheel radius, wheel width, body. It's a circular robot, 10 centimeters radius. I was kind of thinking about my Hoover robot really when I put together the parameters. Okay, so there's nothing difficult there. Then plastic density, again, I thought it was a reasonably reasonable thing to do. And then wheel damping coefficient, I tuned these. Basically, I looked at a few DC motors that are used in these cases. I picked the maximum torque that they can deliver, and then I used the damping coefficient to make the robot not exceed a reasonable speed, like half a meter per second, I think, or a meter per second, so something around that. Then we have the contact force with the ground. So the friction, static friction and dynamic friction, I took rubber on a concrete platform. It's the best thing I found around. That seems, again, I think is reasonable for now. These parameters around the contact force and how the contact between the wheels and the ground are simulated are still a bit of a mystery, to be honest, for me. So I looked at other examples from MathWorks, and I hope they're good enough. They seem to replicate the behavior well. Then looking at the model, I'm not going to explain the model too much because I want to do another video. But basically, the wheels are ideal. So we control them in torque, which obviously isn't right, but it's an approximation for now. Maybe going forward, we will use a DC motor. We will use our DC motor model that I've done in Simscape as well. We'll see. And then what we have, it's essentially, it's a body, which is a cylinder that is free to move respect to the wall frame. And then there are these two elliptic wheels attached to the body, which they can only revolve around the horizontal axis, and they're slightly translated to place them where I think it's reasonable to place them. And same for the front sphere. And then what do we have? The joint of the robot. I've done some play around it to find the speed on the ground and the heading, basically. Okay, just to plot them and have something nice to see. So let's look at the plot. This is the plot. If you remember, the robot goes first. I'm giving more torque on the right, so we're going left, right? So we're going left, which is positive towards the Z axis. Then the torque changes, so we're giving more torque on the left, and we go the other direction, right? So we go towards 90 degrees, more or less, and then we go towards minus 180. This is interesting. Remember that if you go beyond 180 plus or minus, for example, if you go below minus 180, your calculation will probably go to 180 and you will have a big step, which can upset a lot your control system if you haven't done something to cope with that, which we will look at if we carry on this example. Speed increases, then it plateaus more or less around 0.5 meter per second, like I said before. Then you can see the two components on X and Y axis. And I think it's everything really. And the other thing I wanted to say is the way I generated the torques for the wheels is a stair sequence. So it's basically steps. And I found that it was, well, it's not really realistic anyway, but it was upsetting a bit the simulation, probably because of the contact forces. I'm still learning Simscape, really. So what I decided to do is I used the low-pass filter first order downstream of the repeating sequence. So that's why you see these first order responses, okay? As I said, this is a preliminary attempt, really. But give me some feedback. Let me know what you think. If you want me to go ahead and do a bit more examples on this system, if you have other ideas, different systems, I think it's an interesting opportunity. Let me know. Thank you.